morning we have the opportunity to learn from Josh Legler. He's going to talk to us about writing efficient business rules. This will be pretty specific to software developers and state managers, but if you don't fall in within that category, please feel free to stay on and learn as much as you can from Josh. We really appreciate his expertise. Please also know that this is pretty informal and that we do have time in this section to ask questions and to be a little bit more specific to things that you may be dealing with or up against. So feel free to use your chat feature or to unmute your phone and ask Josh a question. And I know he'll also open it up at the end for additional questions. So I think we're good to go. Without further ado, I'll go ahead and just turn this over to Josh Legler. We so appreciate you taking your time to teach us today. Thanks, Josh.
Thanks, Julianne. Let me just get things set up with screen sharing. Great. And Julianne, did that work? You're seeing a PowerPoint slide?
Yep, it looks excellent.
Okay, great. Welcome everyone to this training on writing efficient business rules. My name is Josh Legler. I'm a contractor to the NEMSIS Technical Assistance Center. And one of the project areas I work with is Schematron rules and helping with the national Schematron rules and also providing training and guidance for implementation of state-level Schematron rules. The training today will be a technical training, and the primary audience is vendors. The secondary audience is state data managers. So if you are from a vendor company, the information I'll be sharing with you today includes some techniques that you could implement if you want to build Schematron files for your state customers that would improve the efficiency of the process. If you are a state data manager, it may feel a little technical for you in some areas, but I think you'll be able to see this as understanding an approach that you could encourage your state vendor to use as they help you build Schematron business rules. So you'll definitely get something out of it from that perspective. If you're from an agency level or other areas, this will kind of be a, hey, you get to see the inner workings of the NEMSIS standard as it relates to business rules. I also wanted to mention that the examples that I will be showing today have been designed based on NEMSIS 3.5. However, they are applicable to NEMSIS 3.4 and earlier versions with minor adjustments. Okay, let's, we're going to cover two areas today. The first area we'll just cover real briefly, which has to do with deciding what rules go into your state Schematron schema. And then we'll spend the bulk of the time today talking about this idea of embedding a state data set into a Schematron schema in order to efficiently perform validation things that could be done based on referring to data in a state data set. Okay, so let's start with this first question of what rules should be in a state Schematron file. Let's take a look at this rule. Let's say that this rule was in a state Schematron file. It's an error and it says unit notified by dispatch date time is a mandatory field. Is this a rule that should be in a state Schematron schema? Go ahead and unmute yourself if you're willing to kind of jump out and take a stab at this. Should this one be in a state Schematron schema?
No, it shouldn't be, since this will be covered with the national Schematron.
You're exactly right. Actually, well, you're pretty close to right. It's covered by the National XML Schema, or XSD. Yeah, let's take a look at the data dictionary. In the data dictionary for etimes.03, we see these two attributes right here. Is it nillable? No. The recurrence is 1-to-1. What this means is that the XSD mandates that this element has to exist exactly once on every PCR, and it cannot be empty. It must have a value in it. Okay, so that means that this Schematron error here in a state Schematron file will never be fired. No one will ever see this error. What they would see is the XSD validation error that would occur first, because XSD validation occurs before Schematron validation. So they would get the message through XSD validation. They would never see it from the state Schematron file. So this error message does not need to be included in a state Schematron file. Now, a state may set up a rule like this internally within their state system for people who are using their state system for direct data entry. And that's fine if they have to do that. If their vendor has not already enforced this constraint as part of the XSD, then you set up a rule, that's fine, but there's no need to export it or include it in your state Schematron schema. Okay, let's look at this next one here. This one is a warning. Unit notified by dispatch appears to be out of sequence with other recorded date time values. What are your thoughts on this one? Is this a useful warning to have in a state Schematron file? This is the one a bit trickier, perhaps. All right, let's look at the data dictionary. This is looking at the NEMSIS 3.5 data dictionary, where you can go to the data dictionary page for etimes.03. You can scroll down to the bottom of the page and you'll see this section called Associated Validation Rules. And what it will show you is all of the national Schematron rules that pertain to this data element. And you'll see that there's a whole set of national Schematron rules that compare the unit notified dispatch date time to the other date time values in the patient care report to make sure that it is in a proper sequence with those other values. Okay, so this rule in a state Schematron file is redundant with a national Schematron rule. What's going to happen here, though, is both rules will fire. Okay, so in the previous example with this one about being a mandatory field, this rule will never fire because XSD validation happens first and then everything stops there. But in this case, once XSD validation has passed, then both national and state level Schematron validation will be executed by the software. And the user will receive two error or warning messages. One warning message will be this one from the state, and they will also receive one of these warning messages from the national validation. So what happens here is the user sees two warning messages that are essentially telling them the same thing, and that becomes a usability issue for that user because now they have to figure out, well, are these the same message? They're worded a little bit differently. Maybe they're talking about something different. What do I do to fix this? So it can slow them down a bit. Okay, so this state Schematron rule also does not need to be in a state Schematron file because it's a constraint that's already enforced by the national Schematron rules. The only reason this would be included in a state Schematron file is if a state had planned on changing it from a warning to an error. They wanted to actually reject records based on this constraint. In that case, it would need to be in a state Schematron file because the national file only implements it as a warning and would allow a record to be accepted. So if you're, bottom line is if you're making a rule about a constraint that already exists in the national Schematron rules and you're doing it at the same level of severity, then that's redundant. It's going to show up twice for a user and does not need to be in a state Schematron file. Okay, so keep those thoughts in mind and those tips if you're a state data manager deciding what rules to include in your state Schematron file. And for the remainder of the training now, I want to talk about this idea of embedding a state data set in a state Schematron file. Let's take a look at this rule here. There are quite a few states that have built a rule like this that says that destination code should be a code that's recognized by the state. So, you know, the state has, say, a bunch of hospitals. Each of those hospitals has a code. And when the state receives data, or when data is entered into a local system, we want to make sure that the destination code is actually one of those codes that the state recognizes. There's lots of other rules that could be created that would also utilize stuff that happens to exist in a state data set. Here's a few examples. Maybe the state wants to validate crew member levels. The state recognizes EMR, EMT, AEMT, and paramedic, and those are the only levels they ever want to see in crew member level. Then that's something that they could validate that's based on something that's in the state data set. Or procedures, medications, or protocols. All of those lists live in the state data set. And so the state data set could be used as a reference to validate data that's coming in to make sure that codes are being used that the state recognizes or permits. Here's one that even goes you know, a little deeper. Destination name should be the name recognized by the state when destination code is, you know, XYZ. So this one is saying, well, we're going to look at the destination code and we're going to look up that code, and the state has a particular name for that facility, and we want to make sure that the incoming data uses the same name for that facility. So that one goes a bit deeper, looking up both the code and the name of the destination. So these sorts of rules exist in state Schematron files today. And here's the hard-coded approach to implementing one of these rules. So this rule here is the one that says that the destination code should be a code recognized by the state. The hard-coded way of implementing this is to create a Schematron assert where the test is that the destination code is one of these values. And so then this just gives a comma-separated list of values. If the destination code is one of these, then the assert passes and we're good. And if it's not, then the assert fails. The hard-coded way of doing the destination name matching the destination code, well, that one is significantly more complex. It looks something like this, except that I've cut it off after just, you know, 50 or so of these, because to do, say, 1,000 facilities would be extremely long. But the idea here is they're saying, we're going to do a Schematron report, which means that if any of these things is true, then we're going to trigger a warning. And so if the destination code is this code, but the destination name is not this name, then we'll trigger a warning. Or if the code is this second code, but not this name, we'll trigger a warning. And so we have to list each of these combinations of codes and names right within the assertion test. Again, if you've got 1,000 facilities, that's a really long string of text there for that assertion text. So a couple problems come up with these hard-coded approaches to validating things that are in your state data set. One is consistency and the other is performance. Consistency is the main issue that we will you know, focus on today, but I'll talk a little bit about performance at the very end. The issue with consistency is that whenever you update your state data set, you got to remember to go in and modify the content of one of your Schematron rules to adjust for those changes that you made in your state data set. So it becomes kind of easy for your state data set and Schematron schemas to become out of sync with each other. You add a code to the Schematron rule, but you forget to add it to the state data set, or vice versa. So the alternative that I'd like to discuss today and show how to do is this idea that you just embed the state data set in the Schematron schema. Now, every time you update your state data set, you do have to regenerate the Schematron schema. But since it's simply embedding the state data set you're guaranteed that you'll have consistency between the contents of your state data set and your Schematron rules, because the Schematron rules are actually referencing that state data set. Okay, so the way it works is you have a state data set file with all these different sections, like your custom elements, your meds and procedures, your agencies, your facilities, and that entire state data set file just gets pasted right in or inserted right into the Schematron schema up near the top. And then down in your Schematron patterns and rules and assertions, you can reference the contents of the state data set by doing a key lookup. Okay, so that's what we're going to look at today. In NEMSIS 3.5, state-level products will be tested on their ability to generate a correct state data set for their state. And so this is a technique, I think, that could really be adopted, especially in NEMSIS 3.5. But as I said at the beginning, it'll also work in earlier versions of NEMSIS. So in NEMSIS 3.5, states can be confident that their vendor will be able to generate the state data set for them, all this stuff on the left. And the vendor may also have some features in the product that assist state data managers with creating Schematron files. So this is something the vendor could implement to take all the state data set data and inject it into the Schematron schema so that it can be referenced in Schematron rules. Okay, so let's dive in and we'll take a look at how this is done, and it's actually pretty straightforward. This is the top of a Schematron schema, and it's got kind of the initial stuff, you know, version, title, etc., some stuff that's required by NEMSIS. And what we do is up here near the top of the schema, before the rest of the stuff, we have an element called let. That's a Schematron element that creates a variable that can be referenced later. And we're going to name that variable state data set. And then here's the closing tag for the let. And everything inside of here is going to be the contents of that variable called state data set. And so here, this is where we're just going to paste in all of the state data set, all the way from the opening tag to the closing tag. Okay, so a variable, and we just paste the state data set right in there. Okay, right after that let assignment where we make the variable, we're going to do one other thing, and that is we're going to define a key. This is key is an element that's in the XSL namespace, and it is allowed to be used in Schematron schemas. We're going to give the key a name, so I'm calling my key StateDataSet_facility. This key is going to look for this element, sFacility.facility group. Well, in a state data set, every facility is an sFacility.facility group. So we have one of those blocks of data for each of the 1,000 facilities that are in the state data set file. And then I'm going to have this use attribute, and this tells me that when I use this key as a lookup mechanism, how am I going to find the facility group that I'm looking for? I'm going to find it by looking at the value of sFacility.03 in that facility group. Okay, so every facility in a state data set file has a bunch of data elements about it. One of those is sFacility.03, which is the facility code or ID. So I'm setting up a key, or in other words, an index that allows fast lookups. And I'm saying, whenever I use this key, I'm going to pass a value to this key. That value, then the key is going to use that value. It's going to look in all of the facility groups, and it's going to see if sFacility.03 has the value I'm looking for. If it does, it's going to return that facility group. If there's more than one facility with the same value for sFacility.03, then it's going to return all of them as a sequence of facility groups. So the key is something that just improves efficiency and performance when trying to do these matches. Now that's the key for a facility. I could just as well set up other keys for state data set licensure levels or state data set agencies medications, procedures by level, medications by level, or by medication code, by procedure code. So all of my keys would be defined up at the top of the Schematron file right after I created that let statement with the state data set in it. Okay, so that's the setup at the top of the Schematron file, and then here's how we use it within the Schematron file. Here I have a Schematron rule. The context is edisposition.02, and this little code here means that it's not empty. Okay, so edisposition.02 is destination code. And then I have my assertion here, and the test of my assertion is actually quite straightforward. Instead of being that long hard-coded list of facility codes, I use the key lookup. So I use a function called key, and I tell it which key I want to use. I want to use the StateDataSet facility key. Okay, so if we go back up, it's going to use this key that I defined here. And the value that I want to look up is just this dot here. The dot means the context element of my rule. So I'm going to look up edisposition.02, the value of that element. So let's say someone had a destination code of 123. Then what we're saying is we're going to use the StateDataSet facility key to look up the value 123. So give us all of the facilities that have 123 as their facility code. And then we got to set the context for this key lookup. If we don't do that, then the key lookup is actually going to try to look things up in the file that's being validated in the patient care report. We don't want that. We want it to actually look up data in the state data set that we defined. Okay, so we refer to this variable state data set. If we go back up, that's this right here when we created the let statement. So we're going to look inside of this variable, which contains all of our state data set data. Okay, so again, the key to use is the facility key. The value we're going to try to look up is the value of the context element, edisposition.02, the destination code. And the variable we want to look in to try to find a match is state data set. What'll happen here is if there are no facilities in state data set that have a code that matches our destination code, then this key will return nothing, and that will be equivalent to false, and the assertion will fail, and this warning message will be shown to the user. On the other hand, if there is one or more facility that has that facility code, the key will return data chunks, a sequence of facilities with all of their data. And that would be equivalent to true. And so this assertion would pass and this warning message would not be shown to the user. So that's the straightforward way to embed the state data set and then just use this key lookup in the Schematron rule. What this means is whenever you update state data set data, like the facility list, you don't even have to touch the Schematron rule or assertion. You just update the embedded state data set and regenerate the Schematron file. Let's look at the more complicated one now. This one is going to say that the destination name should be, XYZ when the destination code is 123. This is equivalent to that hard-coded rule that I showed you earlier where it had all those pairs of codes and names, checking each pair. Here's the way to do it using the key and your state data set. So we've already set up the state data set, we've already set up the key, and now I'm going to create a Schematron report element. So this one is going to show us the warning message if it evaluates to true. So it's the opposite of an assert. Okay, and here's the test. We use the key. We're going to use the state data set facility key. We're going to look up the value of edisposition.02, the destination code, in the state data set. And then we're going to check to see if the value of the context element, the dot right here, this is edisposition.01, this is the destination name. Okay, so we're going to check to see if the destination name is equal to And then we do this key lookup again. Lookup in the state dataset facility key, lookup edisposition.02. The context for that is the state dataset. And then we just put something on the end here, sfacility.02. Okay, so what it does is this key is going to return to us the facility that has the facility code that matches edisposition.02 in the patient care report that's being validated. It's going to return that facility and all of its child elements. And so that's why we can simply just look in the child elements of that facility. sfacility.02 is the element for the name of a facility. Okay, so what we're saying is if the facility code is found in the state dataset facility list, and the facility name or destination name in our patient care report is not equal to the name for that facility in our state data set, then we're going to trigger this warning message. And then the warning message can be more precise, because here we're going to say that the destination name should be, and we'll actually do that key lookup again and give them what the value of the destination name should be from the state data set list. So destination name should be, XYZ when destination code is 123 or whatever. So there's how we use the key lookup to do something a little more complex, still relying on data in our state data set. Okay, so the cleanness of this with the consistency is that whenever you update your state data set, that state data set simply gets re-embedded or recopied into the state Schematron schema, and you just republish the state Schematron schema as well. Every time you update your state data set, you just keep the two in lockstep sync with each other. All right, lastly, I wanted to touch on performance considerations. For whatever reason, the hard-coded approach that I showed you for that facility code to name matching rule, it causes a bit of an issue in compiling the Schematron schema. Don't really know why technically this is happening, but if software is using the reference implementation of Schematron that has this three-stage compilation process, for whatever reason, that first stage of compilation takes a long time and uses a whole bunch of memory in order to execute successfully. So if I allocate anything less than 3.5 gigs of memory, it fails. As I noted here, it takes about 15 seconds to churn through that. Again, don't know why that is, but with the embedding of a state data set in the Schematron file, then we see typical processing results for that stage of the compilation. Takes 1.5 seconds and uses very little memory. The other stages of compilation are roughly equivalent to each other. The Schematron or the embedded state data set actually takes a little bit longer on those steps, but it's just a minor difference. And then looking at validation, the validation times are fairly, roughly equivalent. When you're doing a large number of PCRs, then the embedded state data set approach becomes more efficient slightly than the hard-coded approach. But the main reason for that is the output that you get. So when doing Schematron validation, the output of the validation process is something called Schematron validation report language. It's an XML file in a certain format that communicates which assertions failed or which reports passed. So in other words, it communicates all the errors and warnings that were found while validating a file. What happens with the hard-coded approach is that the actual assertion test gets copied over into the SVRL output. And so you'll see huge differences in the size of the output here because the test itself is being included in the output. Let me demonstrate what that looks like. Okay, so here's the hard-coded approach, and here we have a report that fired, and what you see here is the test from that report. All of that is here in the SVRL output. So I mean, it just goes and goes and goes for, you know, there's a line that's 71,000 characters long. When we embed the state data set in the Schematron file, then here's the test, right? This test is not very long at all. It's those key lookups. And so we get a, you know, this line in the file is only a couple hundred characters long. Okay, so that accounts for the difference here in file size of the output. So the embedded state data set approach becomes more efficient from that perspective. Again, from a performance perspective, these aren't huge differences. The compilation of a Schematron file should all be done ahead of time. So when actual validation is done, all of these steps should have already been done just one time as an initial compilation. But those are the differences, both in terms of memory usage, processing time, and the size of the output. All right, so that wraps up demonstrating how to embed a state data set within a Schematron schema. And at this point, I want to open it up for discussion and questions. Anything related to this, but also, you know, if you just have questions, you're just kind of wondering, hey, can we do such and such through state Schematron rules? I'd be happy to answer questions like that as well. So I'll open it up now and see if anyone has questions, comments, discussion, thoughts on what I've shared.
Josh, this is Sharon in Nebraska.
Yes.
So when you were showing the state embedded data set and like where it was referencing to edisposition.02, the code, it was a warning message, but a state could have that be a error message.
Yes, you could. You just simply change the level to error instead of warning.
Okay. All right. That's what I thought. Thanks.
Yeah.
Hey Josh, it's Terry Smith from Iowa Department of Public Health.
Yes.
I guess this might be an obvious question, but why wouldn't everyone want to go with embedding the data set?
Yeah, I agree. I think it's a clean, consistent way of making sure that you always have a matchup between your state data set data and your Schematron constraints. So I just think it's a great way to go. And plus, you know, I showed you today the facility rules, but once you've embedded that state data set, now you've got things open to just go ahead and reference anything in the state data set with your validation rules. So procedure codes, medication codes, agency names for, you know, like other agencies on scene, that kind of stuff, it's all available.
Perfect, thank you.
Okay, any other questions, thoughts, concerns, discussion? All right, so to wrap up, just like I mentioned at the beginning, if you're a software vendor, this gave you some technical guidance on how you could help your state customers to generate Schematron files that embed their state data set within the Schematron file and improve that consistency and performance of Schematron validation with these large lookup lists like facilities, etc. If you are a state data manager, you saw all the technique today, but maybe the takeaway for you is simply that you want to have a discussion with your state vendor and say, hey, what are the chances that you could do this for us or help us with this? So, a couple different routes to take depending on who you are. And as I mentioned, this was specific to NEMSIS 3.5. If you were to implement this in 3.4, there are just some minor tweaks that would need to happen. For example, state data set element names are different in 3.4. And NEMSIS 3.4 uses an older version of the Schematron standard. It uses the 2006 version, whereas NEMSIS 3.5 uses the 2016 version. But the same concept can be implemented, the same technique can be used in NEMSIS 3.4. Okay, with that, Julianne, I'll turn it back to you.
All right, sounds good. Thank you, Josh. Thank you, everyone, for participating today. Let me put up the calendar for next month's training. So April, let's pull this over. April 7th will be an overview of tools available to promote NEMSIS 3.5.0. So that will be same time, same place. Please feel free to share the training calendar or to forward these opportunities to anybody in your organizations that may benefit from that. Oh, I don't think you guys are seeing it. How about?
I see it.
Okay. Oh, good. All right. Thank you. Thank you for being here today. Thanks, Josh, for sharing with us this morning. And thanks, everyone, for taking time out of your busy schedule. We'll go ahead and say goodbye for today, and we'll see most of you on the NEMSIS v3 implementation call next Wednesday. Thanks, everyone. Have a great day.
Thank you.